All right, people. So this is a quick, rundown of some of the important things in 2.4.1, which is while loops. A pretty important topic. Um, Basically, your while loops, you have stuff that happens before your loop, like prompting a user for input. Then your loop header, which has your while and the Boolean. And then you'll do the loop body over and over again. That's why it's called a loop. And it keeps checking, is that header still true? Okay, I'll do this. Is that header still true? I'll do this. I'll do it. And then as soon as it's not true, you jump to the stuff afterwards. So you'll see sometimes it's easy as just, printing stuff out. Other times you'll do it and it won't even see the loop. So this is an example of when you have no way to enter your loop. It just jumps right past it if it's not true. And that's something you want to be careful of when writing your loops. You want to make sure there's a way to get into your loop, and you want to make sure there's a way to get out of your loop. So here's one that does both well. It gets in your loop with a 1 that's less than 11. It keeps adding to it, so it gets out of your loop also. This one sets it too high, and it never is true, and it jumps right past it. And then even worse is this one. Well, not this one. I would call this like a trapping loop. Like you can enter anything, it'll keep you in your loop until you enter Q, and then it lets you out. So it traps you while your input does not equal quit. This one's the worst case scenario where you start at 1, which is bigger than 0, but then you keep adding to it, so you'll never finish this loop. You'll get trapped forever. It'll probably freeze up your computer eventually. So basically, here's our syntax for Java. You gotta have the word while, in parentheses, a condition, a Boolean, much like an if statement, and then something it's going to do over and over again. So you want to make sure that you have a way out of it. And there's 3 different ways to write it. I usually prefer this way just because it looks prettiest. You could write it all in one line, and you could write it with like start. A lot of people like to start the brace here and then brace there. Saves a line of space every time. So yeah, you can write your code to count here. And I showed 2 different ways. Here's one way. You can go from 9 to less than 20. And you're like, why is it print from 10? Because sometimes you might want to add before you print. And other times, if I cut this out and put it above and run it, well, now I'm going from 9 to 19. I would want to start at 10 and go to less than 21. This is probably the normal way to do it, where you print and then add. Once again, I have a way to get in my loop. I have a way to get out of my loop. Okay, and then, sorry. This stuff, you can go through here. The month chooser is pre-built for you. Don't spend like a ridiculous amount of time on the student chooser, because I don't know, you're just modifying their code from months to students. I wouldn't stress out too much about that problem. And then let's get to some more interesting stuff at the bottom, standard algorithms and stuff like that. So on number 20, this is actually kind of a hard thing to do, because they told me I'm not allowed to use modulo or division to check if something's divisible. Because I could think of a real easy way to check modulo. Does the modulo equal 0? And if I use division, I could just see if it was an integer version of itself. So if it goes in nicely, it would go in as an integer. Oh man, so this one's kind of irritating, where you're going to have a dividend and a divisor. But if you think about how division works, it's really just repeated subtraction. Like, for instance, if 12 is divisible by 4, that means I can take chunks of 4 away until there is 0 left. If 12 wasn't divisible by a number, so let's say 5, well, let's do 4 again. So if I do 12 minus 4, I get 8. If I do 8 minus 4, I get 4. If I do 4 minus 4, I get 0. 12 is divisible by 4 because I can repeat subtraction until it gets to 0. Now, if I picked a number that didn't go in nicely, it wouldn't get to 0 eventually. So I do like 12 minus, if I'm checking if it's divisible by 5, I do 12 minus 5, and then it would come out to be 7, and 7 minus 5 is 2, and 2 minus 5 is negative 1. As soon as I get that answer and it doesn't actually equal out to 0, then I know it's not divisible. So basically, we can do this nonsense with 2 while loops, really. We can start off by doing, okay, I need an integer for my divisor. I'm going to set my integer equal to my divisor. Okay, because we want to check what's left over. Okay, scrap that. I want that to be the dividend. So the number you're dividing into. And then I also want an integer to have what I'm going to repeatedly subtract. Which is going to equal my divisor. So like in my example that I was talking about, so this is like how much is left. So right now, like if I said I start with 12 and I want to see if it's divisible by 4, my 12 is my dividend, my divisor is 4. Right, I start with 12 to begin with, and I start subtracting 4 and 4 and 4 until I get a number that's, not 0. So we're going to do a while loop. So while my leftovers are greater than 0, I'm going to take my leftover and subtract my repeated subtraction. Now we could do this with we could do this with a minus equals too, but I think it's nice to see this. You're like, okay, so I started with 12, and I take my 12 minus 4, and then I'll do it over and over again as long as I'm bigger than 0. And then if it's done doing that and it equals 0, so if my leftover, I should spell that right. If leftover equals 0, come on, I can do it. Then you'd say something like the divisor, so you'd say system out print, and you'd say that dividend plus is divisible by space, and then you put divisor. Okay, so you could say, hey, yeah, if the leftover, the remainder, basically, you do repeated subtraction, it comes out to be 0. Else, you would say, dividend plus is not space. Let's see if that works. Okay, that's weird. I wanted to do this one because it is bizarre. Oh, crap. What did we do? Let me check this out. I done messed up. Pause this and figure out my error. Okay, apparently I can't spell dividend. That's an issue. And other errors too. Let me figure this out and come back. Okay, my second issue was apparently I can't spell print. So if I try 12 and 4, it goes in nicely and hits this part of the code. where the leftovers are 0. If I run it again and I do 12 and 5, there you go. So yeah, that was weird. I wanted to hit that because why wouldn't you just use modulo? I don't know. Oh well. And I think another interesting thing here is I've seen AP ask this before on write an algorithm that prints the individual digits in a number. I've seen it used in arrays and lists and basically sorting methods. So this is a good chunk of code to do. So basically there's a scanner and they're going to say enter an integer to see its digits, as if you didn't know. But you're going to enter in like 564 and it's going to print out, like a 5 and then a 6 and then a 4. So it didn't really say what order you had to print out the digits in. So we're going to use a while loop. And we're going to say while our number is greater than 0, we are going to do something to it. We're going to print out I'm going to make sure I spell this right. System out print line. So we're going to first print out the last digit. And to print out the last digit, you can modulo 10 it. So if you divide something by 10, whatever the last digit is will show up as the remainder. So we're going to take our number modulo 10. So if I did that to like a 73, my answer would be 3. So if you just did that, it doesn't really change your number. So what we want to do is make this thing actually take my number down a notch. So that's to read off the last digit. If I want to chop off the last digit, so I'm printing it, right? Printing it doesn't actually change my number. And remember, you need a way out of your while loop. If you just did this, it would just keep on keeping on. It would do it a million times. So the next thing I want to do is actually chop off the last digit, which is just to reset number as number divided by 10. Now, why does that work? Because it's an integer. And remember how we truncate with division? It'll just chop off the decimal. So this prints out the last number with modulo. It chops off the last number with division, since they're integers. So if it was 564, the first time it would print out a 4, and then it would divide it by 10, and you get 56.4. But since it's an integer, you'd be left with just 56. And then it would go through again. Is 56 greater than 0? Yep. So now it prints off the 6, and then it cuts off the 6. And then you're left with a 5. Is 5 still greater than 0? Yep. So it prints off the 5, then it cuts off the 5 and makes a 0, and then it would, skip past it and be done. Let's see if it works. 564. There we go. There's the digits, 465. Awesome. Good times, good times. Okay, and the last thing I wanted to do is at least get you started on number 23 because it's a little vague on how you're supposed to get a bunch of user-provided integers without string methods. Well, the without string methods is not a big deal. First of all, you can tell they want a scanner. So the first thing you got to do is figure out, build a scanner item. That's from before. You can look that up in your past. And then first say, enter the number of values you would like to analyze. So if we're going to try to find the min and max of a number of values, first thing you got to do is figure out how many values the user wants by taking, the scanner.nextInt and storing it as number of entries. Then we're going to want a while loop. So we probably want a counter here. So while count is less than number of entries, we're going to continually ask them for another input, right? We're going to say int entry input equals. Okay, so you're going to get an input from them. You're going to check if it's bigger than your old max or smaller than your old min. So up here, you're going to have to figure out with the integer class what max value is and min value is.